Pretty much.
Okay, same type of idea. We're going to be using tables to graph, but this time we're going to do something called a quadratic. So a quadratic, if you guys recall, makes somewhat of a U shape. It's called a parabola. So we need to create something like that. Now, in this example, they have not given us any values. Okay? So what I'm going to do is I'm going to choose some values. So I'm going to start at -2, -1, 0, 1, and 2. Now, there could be a downside to this. Because I'm choosing numbers at random right now, I may end up plugging a number into this equation that gives me a value. Let's say, for argument's sake, this becomes 53. That will not fall on this grid. So in order to graph this, we have to make sure we find y values that do fall on this grid. Okay? So, the idea is the same. Our x value, we still plug it in for the x in this equation. Both. Because there's two of them, we have to do it twice. So y is equal to, I just replaced the x with -2, is still squared, minus, so if you guys notice, minus -2, minus 6. Now, -2 squared is a negative times a negative, so we'll get +4. This is like having a 1 here. -1 times -2 is +2, because we have a negative times a negative. And then subtract 6. What are we going to get here? 4 plus 2 minus 6? 0. So our y value is 0. So this coordinate will fall on, it just so happens. I chose them. I just picked them at random. As long as it falls on your graph between, like most of our graphs are between -10 and +10, choose numbers between those. Yeah. Okay, so here's our coordinate. Okay, so we have that. Next thing we need to do is the next value. So -1 into the exact same equation. Y is equal to, in this case, -1 again, squared, minus, put it in red again, -1, minus 6. I'm going to go a little quicker this time. -1 squared will be a positive value of 1. Negative times a negative will give us positive, so we get +1, minus 6. This becomes 2 minus 6. So -4 is our y value. So here's our next coordinate, -1 and -4. We're going to continue this pattern because we want to eventually get to the top or bottom of a parabola. We're hoping to find what's called the vertex. So next we're going to plug in 0 into the equation. Now 0 is an easy one to plug into an equation like this. Okay? 0 squared minus, that's right, it is just going to be -6 because those zeros are all pretty much going to cancel themselves out. This becomes 0 minus 0, that is nothing. So the only value left is -6. So now we're at -6 here. Okay? Next value we plug in is +1. I'm going to stop writing them in red just to speed this up. So we get 1 squared minus 1 minus 6. 1 squared is 1 minus 1 minus 6. What's that going to give us? -6. Okay, we've got -6 here, and that's going to go here. And then finally, our 2. Anyone have an idea what that's going to be? It's going to be this -4 again. Okay. It's not quite -6. So there's something we got to figure out here. I have these values again. I'm going to put a graph on the second page. Let's put up a graph again. We'll make it much larger so you can see. Okay, now this is what's important here. We're going to plot these again as best we can. So -2 and 0, that's x at -2, y at 0. So that would be this coordinate right here. The next one's at -1 and -4. So -1 and -4 is down here. 0 and -6, so that's when x is 0, y is -6. 1 is at -6 again. The next one's going to go up to -4, and then we can kind of guess from there that the next one is going to go up to 0 again. So we can't have a vertex that's on the same spot. So really when we go to connect that, we're going to estimate that the vertex is probably between those two values. So it probably dips just a little down and then comes back up. We don't have to be perfect. We just have to get a general shape of this. Okay? So the vertex was probably between those values, maybe at something like 0.5. But we used whole numbers so that the question would be much easier for us. And that's fine. We're just trying to get a general sketch of this graph.